Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In our most recent episode, physicist Wal Thornhill outlined some of the emphatic predictive successes of the electrical theory of the nature of stars. Stars do not form in processes of gravitational collapse and accretion, but rather they form from the electromagnetic Z-pinch effect along vast networks of filaments, often in binary pairs. Stars are not powered by an internal thermonuclear reaction. The interstellar Birkeland currents along which stars are born continues to power them throughout their lives, with electrical energy producing heavy elements near the surface of all stars. Stars do not explode in supernovae because they exhaust their nuclear fuel and then collapse. Rather, a star has internal charge separation, as well as electromagnetic energy stored in its equatorial ring, and it ejects matter in the form of electrical discharges, as seen in a star's bipolar jets, or catastrophically in the form of a supernova. This new picture of stars is essential when considering one of the most mysterious phenomena in the cosmos, called a pulsar. A pulsar is a regularly pulsing source of radio waves and other types of electromagnetic radiation. Since their discovery more than half a century ago, astrophysicists have proposed that pulsars are caused by hypothetical objects called neutron stars. First suggested in the astrophysical literature more than 80 years ago, a neutron star is believed to be an incredibly small yet massively dense star, mostly composed of tightly packed neutrons, which forms when the material from a supernova explosion of a massive star collapses gravitationally. The average neutron star is thought to be around 10 to 20 kilometers in radius, yet supposedly has about 1.5 times the mass of our Sun. As described on an official NASA webpage, quote, "A neutron star is so dense that on Earth, 1 teaspoonful would weigh 1 billion tons. A spinning, magnetized neutron star is thought to act very much like a lighthouse, with the light beams becoming visible on Earth with each resolution of the star. If the source of such a signal is a mechanically spinning lighthouse, then it must be spinning incredibly rapidly, sometimes up to several hundreds of rotations per second, or tens of thousands of RPM. In several Space News episodes, we have reported on discoveries which challenge the very underpinnings of the neutron star hypothesis. This includes pulsars whose apparent brightness exponentially exceeds their absolute theoretical limits. In 2014, we reported on the discovery of a so-called neutron star that appeared to shine with the brightness of 10 million suns. More recently, scientists using data from the ESA's XMM Newton satellite reported their observation of the so-called brightest and furthest pulsar ever observed from Earth. The pulsar reportedly exceeds by 1,000 times the theoretical limit for such an object's brightness. The lead author of a paper on the findings stated, "This object is really challenging our current understanding of the accretion process for high-luminosity stars. It is 1,000 times more luminous than the maximum thought possible for an accreting neutron star. So something else is needed in our models in order to account for the enormous amount of energy released by the object." But the impossible brightness of distant celestial objects is a direct result of assuming that redshift gives the distance of those objects. The late astronomer Halton Arp proved that redshift is a measure of youthfulness, not distance. So the impossible brightness then becomes normal for a nearby object. It also means that the expanding universe of the Big Bang does not exist. In other instances, scientists have detected pulsars which appear to, quote, defy the laws of physics. One such object baffled astronomers in 2013, when it was found to switch suddenly and unpredictably between radio and X-ray emissions. The lead author of a paper on that discovery stated, "The people creating models will have to rethink what we are discovering here. When we look now to what is so far published in papers, nothing at this moment can explain what is happening." And today, scientists are again puzzling over the behaviors of a so-called neutron star which completely confounds their theoretical models. As reported by Science Alert on September 27, 2018, Roughly 24,000 light-years away from Earth, in the constellation of Cassiopeia, is a dead star that shouldn't exist. Not, that is, according to current theory. The neutron star, accreting material from a much larger binary companion, is spewing out relativistic jets. The problem is that it also has a strong magnetic field, and relativistic jets have only been observed in neutron stars with magnetic fields 1,000 times weaker. So, our current understanding of how relativistic jets work simply doesn't account for this weirdo. The quote, neutron star has a magnetic field that scientists estimate to be 10 trillion times stronger than that of our sun. Yet standard theory holds that such powerful magnetic fields in a neutron star would actually suppress the emission of relativistic jets. However, it appears that no number of neutron stars that, quote, shouldn't exist will actually persuade astrophysicists that they don't exist. We asked retired professor of electrical engineering Dr. Donald Scott to outline some of the fundamental objections to the neutron star hypothesis, and to explain the promising alternatives offered in the fields of plasma cosmology and the electric universe.
I looked at this press release entitled, "Astronomers have found a strange neutron star that, quote, shouldn't exist." Well, I agree with that title right off the bat, because none of them should exist. The neutron stars don't exist. But anyway, let's go past that point. So the subtitle of the article says, "Looks like our current theories are wrong." Amen, Brother Ben. Yes, most of your current theories are wrong, especially when it comes to something like a neutron star, which doesn't exist in the first place. But anyway, the article says that about 24,000 light years away is a dead star that shouldn't exist. Not, that is, according to current theory. The neutron star is accreting material from a much larger binary companion, and it's spewing out relativistic jets, and the problem is that it has a strong magnetic field. Now, all right, there's about 4 different concepts in there. Magnetic fields, yeah, that's fine. We all know that there are magnetic fields in space. Astronomers came to that realization late, but they're there now, and that's good. As far as the jets are concerned, yes, absolutely. There are these relativistic jets, or at least jets. The exact speed of the particles in the jet is unclear sometimes, but this idea of a neutron star is just plain wrong. Here on Earth, there's a field of study called nuclear chemistry, sometimes called nuclear physics, but in nuclear chemistry mainly is this idea of what goes on in the nucleus of all the known elements. And the atoms of the known elements need a certain ratio between the number of neutrons in the nucleus to the protons that are in the nucleus. You can't have an atom with just neutrons or just protons, otherwise the thing will come apart. A single neutron, we know, will be stable for a few minutes, but in around 14 or 15 minutes, a single neutron just splits up into a proton and an electron and a neutrino. So how in the world are you going to pack the gazillion number of neutrons you need together to get a neutron star? Because having too many or too few neutrons relative to protons results in an unstable radioactive nucleus, and it's going to break up and go into a more stable form. So at its root, this idea of a neutron star has a problem. In fact, it has, I think, a lethal problem. They just don't exist.
We have reported on numerous discoveries which defy the belief in gravitational accretion at all scales in the cosmos, including in the formation of comets, asteroids, planets, and stars. Indeed, scientists observing the disks of material around so-called young stars recently reported that the material required to form planets simply isn't there. We asked Dr. Scott his thoughts on the notion of a so-called accreting neutron star.
This idea of an accretion disk, they use the word accretion several times in the article. And I have a little quote here from my book. I said, the assumption that a spinning cloud of gas, dust particles under the influence of gravity alone accretes into a star or planet or galaxy is false. The answer to the question about how the spinning disk loses its angular momentum usually involves friction. You got this spinning disk out there in cosmic space, and it's spinning around, and somehow it it slows down and collapses because if you're like an ice skater who brings his arm more and more closely in toward his body and then spins faster and faster, the contracting cloud would spin faster and faster if it actually accreted and grew smaller. So the increased spin rate would counteract the collapse. But no, they say, well, but that friction slows it down. Well, friction with what? There's nothing out there to have friction with.
We have suggested that many of the so-called anomalies surrounding pulsars can be resolved if the source is a lightning-like electrical discharge. In fact, this idea was proposed in 1995 in the scientific paper Radiation Properties of Pulsar Magnetospheres, Observation, Theory, and Experiment by co-authors Dr. Anthony Peratt and Kevin Healy. They examined well over a dozen pulsar anomalies that the standard lighthouse model has failed to explain. Using electromagnetic particle and cell simulations, they proposed a, quote, magnetospheric disk field-aligned current transmission line system as the origin of the observed radiation, with external wave excitation by as yet an unexplained source. We asked Dr. Scott to explain some of the theoretical possibilities this research opens up.
Pulsar is a point out in the cosmos that astronomers look at with their telescopes and their spectroscopes and all sorts of things, and they see that this little star way out there is blinking quite rapidly. Some of them blink, every 10 seconds or so. Others blink every second. Others blink every millisecond. And so the question is, well, what's going on out there? And what the astronomers came up with was this idea, well, it's like a lighthouse. It's a rotating beam of light, just like a lighthouse. It goes flash, flash, flash. And then that's why they're there. But then, of course, when they became millisecond in their period, they flashed on and off in thousandths of a second. That means this star, or whatever it is, has to be rotating at a rate of hundreds of RPM, or maybe even thousands, and actually tens of thousands of RPM. And if you get something 10 miles across rotating at 10,000 RPM, it's going to fly apart. Well, okay, then it isn't made out of regular material. It's made out of neutrons, closely packed, heavily packed in neutrons. Well, after a while, they began to look at more and more of these pulsars. They realized that the speed necessary, even for a neutron star, was beyond the speed of a dentist's drill. It was in the tens of thousands of RPM. And so they said, well, that's strange matter then. And so they came up with a new hypothesis to take the place of the old hypothesis. The old hypothesis, the neutron star, of course, as I point out, is wrong. But this now replacement hypothesis of strange matter is also wrong. As far as the actual cause of the pulsars, there is a well-known circuit in electrical engineering called a relaxation oscillator. And years ago, Tony Peratt, along with a fellow by the name of Healy, is the author of a paper that explains how electromagnetic pulses on a transmission line bouncing back and forth like a water wave bouncing back and forth in a nut dish that you lift the one side and then the other side, and then you can get this thing to slosh back and forth. Well, you can do the same thing with voltage waves on a electric transmission line. And if things get out of control, that's how the famous Northeast blackout occurred. These bouncing voltage waves back and forth, knocked out the breakers at the end of the line, and the whole city of New York and everybody, half the country, went black. But anyway, that is the real cause of these pulsars. Probably it's an electrical phenomenon. You can make them in a sophomore electrical engineering laboratory, and you can make them blink on and off with little neon tubes, and it's a very simple matter to construct a relaxation oscillator out of a gas tube. Well, what's a gas tube? Well, it's a plasma. And so right away you come back and say, oh, these things are a plasma phenomenon, an electrically driven plasma phenomenon due to an intermittent signal going back and forth along a transmission line. And since many of these pulsars are binary stars, there's in all probability some sort of a plasma connection between the two binary stars, at least if they're close enough. And there is a perfect setup for a pulsar. So you don't need neutron stars or strange matter or any other kind of red or green ghosts. Just electricity and some plasma will do it for you fine.